Welcome to the DIY Honda Garage channel. The DTC P2195-00 indicates a problem with the air-fuel ratio A-fin sensor, specifically sensor 1. When this diagnostic trouble code is triggered, it usually means that the A-fin sensor's output voltage is stuck in a higher than normal state, suggesting a lean fuel mixture in the engine. The A-fin sensor plays a critical role in regulating and maintaining the appropriate air-fuel ratio necessary for combustion. It is typically located in the exhaust manifold upstream of the catalytic converter, where it can accurately measure the unburned oxygen in the exhaust gases. The Engine Control Module (ECM), also known as the Powertrain Control Module (PCM), relies on the A-fin sensor's feedback to adjust fuel injection and enhance engine efficiency. When abnormalities are detected by the PCM, it stores the P2195 code to alert technicians of the issue, calling for a systematic approach to troubleshoot and resolve it. The AF sensor, or air-fuel ratio sensor, is essential for determining the correct balance between fuel and air during combustion. An output voltage beyond specified limits indicates the sensor is malfunctioning, leading to an incorrect air-fuel mixture. When the AF sensor detects that the mixture is too lean, it sends a high-voltage signal to the PCM, prompting the system to store the P2195 code. Located in the exhaust manifold, this sensor's position is critical for effectively monitoring exhaust gases before they enter the catalytic converter. The functionality of this component directly impacts engine performance and emissions. A malfunctioning AF sensor results in inefficient fuel usage and can lead to elevated emissions, thus responsible for potential operational failures if not addressed promptly. There are several possible causes for the triggering of DTC P2195-00. One likely cause is contamination of the mass airflow MAF sensor and intake air temperature IAT sensor, leading to erroneous readings. If there is dirt or debris obstructing the MAF sensor, its inability to provide accurate air intake measurements can severely impact the air-fuel ratio. Another potential cause could be an installation issue with the AF sensor. If it's incorrectly connected or loose, it could result in signaling errors to the PCM. Lastly, if all other components are functioning properly, the issue may stem from a faulty PCM itself, which could malfunction in processing the sensor inputs effectively. Therefore, a thorough investigation of these individual elements is crucial for accurate diagnosis. Symptoms associated with DTC P2195-00 typically manifest as poor engine performance, including hesitation during acceleration or unstable idle speeds. The incorrect air-fuel mixture can lead to inefficient combustion, causing the engine to operate poorly and possibly stalling. Additionally, increased emissions might be observed due to incomplete combustion, which can negatively impact the environment and may cause the vehicle to fail emissions tests. The check engine light on the dashboard will illuminate, providing immediate feedback to the driver that there is an engine-related issue requiring attention. Recognizing these symptoms early and accurately diagnosing the root cause can help mitigate further damage to the vehicle's engine and exhaust systems. The first step in troubleshooting DTC P2195-00 involves starting the engine and holding the engine speed at 3,000 RPM without load, either in park, P, or neutral. This is an essential step to validate the operational state of various components involved in the air-fuel management system, particularly the AF sensor. By increasing the engine RPM, we can observe the sensor's response under a more dynamic condition. Notably, the radiator fan should engage during this process, indicating that the engine temperature is reaching thresholds that require cooling. If the fan does not activate, you may need to investigate further to ascertain whether the engine cooling system is functioning correctly, as a non-responsive fan could complicate the diagnosis of the AF sensor's output. The second step involves a visual inspection of the MAF sensor and IAT sensor to check for any dirt or debris that may be present. Given that these sensors directly measure incoming air, any particulate matter can skew the functional accuracy of sensor readings and lead to incorrect fuel mixture calculations. Thoroughly inspect the sensors to ensure that they are free from dust, oil, or any type of obstruction. If foreign substances are found, they should be carefully cleaned or the sensor replaced to restore proper functionality. This examination helps rule out potential external factors contributing to the abnormal air-fuel ratio signal. It's crucial to document any findings during this inspection, as they may inform further testing or repairs required in this process. The third step in troubleshooting DTC P2195-00 requires checking the installation condition of the AF sensor, Sensor 1. Proper installation is vital for ensuring accurate data transmission to the PCM. Begin this process by inspecting the sensor and its wiring for any signs of looseness or improper connections. Make sure that all connectors are seated properly and secure to prevent intermittent connectivity issues that could trigger lean conditions. If you discover that the AF sensor has been incorrectly installed, it needs to be reinstalled correctly to eliminate false readings. This kind of oversight can directly impact the overall air-fuel balance and subsequently influence engine performance and emissions. The fourth step focuses on the inspection of the PCM. After ensuring that both the MAF, IAT sensors and the AF sensor have been checked and verified to be functioning correctly. If these two components are in normal working condition, the issue might lie within the PCM itself. Conduct a thorough diagnostic check using the Honda Diagnostic System, or HDS, to analyze the PCM for faults. Carefully review the results to ascertain if the PCM is processing information accurately from the AF sensor and MAF sensor. Should any faults or abnormalities be detected in the PCM, this could indicate internal issues warranted for repair or replacement. Proper attention to the PCM is essential to ensure effective operation of the entire engine management system. After all necessary repairs have been completed, the final step involves verifying the repairs made on the vehicle. Begin by using the Honda Diagnostic System, HDS, to clear any stored DTCs, including P2195. Once cleared, conduct a test drive to evaluate the vehicle under various operational conditions. It is important to monitor performance and observe if any symptoms reappear during the drive. After the test drive, perform a final scan with the HDS to ensure no DTCs are present, confirming that the issue has been successfully resolved. This final verification process is crucial as it validates the efficacy of the repairs performed and reassures the customer of the vehicle's reliability. Preventive maintenance can significantly reduce the chances of experiencing DTC P2195-00 in the future. One proactive measure is to establish a regular cleaning schedule for critical sensors such as the MAF and AF sensors. Keeping these components clean ensures they can function correctly without obstructions. Additionally, during routine maintenance checks, it is essential to inspect the installation of these sensors to confirm all connections remain secure and undamaged. Another important aspect is to ensure that the vehicle's PCM software is regularly updated, as manufacturers often release updates to enhance performance, efficiency, and compatibility with various vehicle components. These preventive measures can collectively ensure long-term reliability and optimal engine performance. In summary, The DTC P2195-00 signifies a malfunction within the air-fuel ratio sensor system, leading to unbalanced air-fuel ratios that jeopardize engine performance and emissions compliance. Thorough troubleshooting must encompass inspection of several interconnected components, including the MAF/IAT sensor and the PCM, ensuring their integrity before concluding any faults. The importance of following these procedures is paramount for accurate diagnosis and effective repairs. Finally, integrating regular preventive maintenance practices into your vehicle care routine can substantially reduce the likelihood of future occurrences of this diagnostic trouble code. By staying vigilant and following a proactive maintenance strategy, vehicle owners can ensure optimal vehicle performance and reliability. Please like and subscribe to the channel. See you next time!